so that I could not. So we'll continue now. So last we have seen access modifier, right? Any question from previous classes? One second, I'm sharing my screen. Okay. So last class we have done with access modifiers. If no question, we'll continue. Next is method overriding. Method overriding. Then method overriding is method overloading we have seen, right? Say we have a class A and class A is having void show is a method, no parameter, some implementation of the method, and we have another same method named show but a parameter, right? This is called method overloading, or void show another parameter string type like this, right? So this is method overloading, means in one class when you are implementing multiple methods with the same name, right, with the same name, then that is called method overloading, right? And the rules you have to follow: method name should be same, then only it will be overloading, otherwise new method it will be called. And when you are overloading, the parameter of the method should be different. It can be in terms of numbers, or it can be orders, or it can be type of the parameters, right? Method return type will not be considered in case of method overloading. And now we have already seen inheritance. So method overriding is, say we have class A and class B extends A. Extending in the sense it will be inheriting these methods. One second, guys. So these properties will be inherited right into subclass, but in case of inheritance, we need to consider the accessibilities. Those we have discussed in the last class. So these method will be inherited. Consider these are in the same package, a class A and class B in the same package, and these methods will be inherited. So if we create a, let us take an example itself. I will not create any package now. Directly we will use. So test test 145.java, and package and import we are not using. Test 145. Right. Class A is having these methods, and let us take one method only as of now. it has an implementation that is print line show method in A class, right? And B class is extending class A. So show method will be inherited in class B also. If we create an object of B, B1, new B, right? B1 dot show, which is the inherited one. Okay, in B class we don't have show method, but inherited show method from A class is also present in B, and creating B object and calling the show method. So the output should be show method in A class. Test 145. Let us compile that. Java C test 145.java. Done and execute. Test 145. Right, show method in A. This is inherited method is calling. So now what I'll do is, it is inherited. Okay, take a new method here, void disp method. And in disp method, we have implementation like this. Disp in B class. Now B object is already created and B1 dot disp also we can call, right? Now in B class two method, one is inherited and one is newly implemented. Again compile and execute. Test 145 and execute, right? B disp in B. Now again, if I rewrite this method in class B, okay, then the existing which is inherited show method which is inherited in B, again if I rewrite like this, same method, everything same, just implementing again, and now I'm saying here show in B class. Okay, compile. Now this output which was previously show method in A should be changed to now, because the class is having its own implementation, so it will not use the inherited one. The implemented, newly implemented method will be called. So this output will change to, now it will not be this one. Instead, the output will be show method in B class. Okay, this should be changed. Implementation is changed. So the newly implemented functionality will be called. Okay, compile again, test 145 and execute. Okay, now it is coming from B, not the inherited one. It is taking the newly implemented one. Okay, so this is called method overriding. Overriding is inherited method, again you are rewriting in subclass, is called method overriding. Okay, so now in class B you have two method, which is show, it is an inherited one, and disp, sorry, it is overridden one. This is not overridden, newly implemented method. Okay, this is overridden, this is newly implemented. Why this is called overridden? Because it was already there, inherited one, you are rewriting it, that is why it is called overridden. It will not use this one now, it will be calling the implemented, newly implemented method. This is called method overriding. Okay, so method overriding definition is inherited method when you are rewriting in subclass, that is called method overriding. Any, okay, but you remember, you need to follow certain rules. In case of method overloading, we have seen rules. The rules is, when you are overloading, the method parameter must be different in case of order, number, or type in any one of that, and the method name must be same. Return type will not be considered. Similarly, in method overriding also you need to follow certain rules. Okay, first of all, why we need overriding? What is the use of method overriding? Okay, method overloading use. Why you are using method overloading? To achieve the polymorphism, right? We already discussed. One name, many forms. Show name, the method name is show only, but depending on the type of parameter which you pass, different method will be called. That is polymorphic, right? If you have a1 object and say new a, and you are calling a1 dot show, suppose show method you are calling. Currently it is not having any argument, so it will be calling this method. I'll not change anything, just parameter is changed, and the parameter is suppose 8 9. Now the same name, but we'll call this one. Or say I'm changing these to this. Now it will not call this one, instead it will call this one. So same name remains same, show only, but depending on the type of parameters, different functionality is working. That is called polymorphism, polymorphic behavior. That is the use of method overloading. Okay, method overriding. What is the use? Method overriding is, suppose class A is defined by somebody. You are not designing the class A. Someone is already designed class A and it is used in many different places. Okay, maybe another class is there, class X, which extends A. Maybe class hello is there, which extends A. Or maybe for class A already one, somebody is using A1 new A and A1 dot show, something like this. Now A class is already designed and it has so many uses. Maybe in your application A class is designed, show method is also implemented, and so many different places class A is already using and its function is also using. Or maybe you are creating an object of A and show is also using. Now your requirement is, for your use, the implementation of show function in class A is not fitting your requirement. Okay, it is not matching your requirement. What you have to do, you need to change the show method according to your requirement. But if you change it here, in all other places, whoever is using show method, their functionality will change. It will affect in so many different places. You should not do like this. You need to change it only for your use. Others should not be disturbed. Okay. So for that, what you have to do, you take a class extends A and change this functionality here instead of changing in A class directly, which may affect in other places. You extend your class A and change the show method in the B class, your class which you are implementing, and do the changes in this new one, not the existing one. Okay. So for any class which is already designed, is closed for modification, those are not supposed to be changed. Okay, you should not do any modification. If you need any modification, then you inherit those and do the changes, not in the existing one, because it may disturb in so many different places. Okay, so this is the main use of method overriding. Okay, method overriding. Or this can be one case. Another case is, say class A is there, show method is also implemented, that is also okay, but you need some other information in the show method. Okay, you need other information in the show method. Maybe you need a requirement, whatever is there already should print, and it should print this statement also. Okay, existing functionality you want to change. So those also you have to do after overriding. You have to override and do the changes. Already implemented information you need. Apart from that, you need some more information or some more functionality it has to perform. You do it in the overriding method. Okay. Or another use is inheritance. We have already seen why inheritance is required. Class A is there already. So many different people are using that class A. You need to add some more functionality. Means in the A class, you need to add disp. You should not do that in the A. Okay, disp method should not be added in the A. It can disturb some other users. So you inherit class A to B and then use the display method there. So these can be the use of overriding or inheritance. Okay, you should not disturb the existing functionality, inherit those and do the changes in the inherited one, not in the existing one. So this is why you need overriding. Okay, first one is what is overriding. Overriding is in the implemented class, implemented functionality, you subclass it and re-implement the functions. That is called method overriding. Okay, why you need to override? Classes are not supposed to be modified. These are closed for modification. If you need any modification in the class, you inherit and do the modification, right? This is the use of overriding. Now you need to follow certain rules. When you are overriding a method, you need to follow certain rules. What are the rules? Rules are, when you are overriding, first of all, the method name must be same. This method name and this method name must be same, then only it will be overridden. Otherwise, if you change the name, it will be a newly implemented method. It will not be overridden method. Okay. So this is what already we did here. Next is method parameter. Okay. Parameter must be same in terms of orders, numbers, and type. For example, in show method, we don't have anything, no parameter in it. When you are overriding, there is also no parameter. If we have another method, void add is the function, which is not returning anything, but it has A and B. It is performing some addition. Okay. So, okay, let it return the result also. Int. And then you are telling return A plus B. Simple addition. Now, if I want to override this, then in the inherited method, exactly same. Okay, exactly same. Parameter must be exactly same. Implementation can be different. Okay, you can have it like this: set n plus constant and then A and B. You are doing this addition and returning. But here, this is not the implementation. Implementation is just A and B, do the addition and return the result. But here, this is the implementation. Maybe it can be different also. But in case of parameters, parameters must be same in type, in terms of orders, numbers, and type. If you change the parameter, what will happen? Say int C also I'm taking another parameter. Now, this method is already there, which is inherited. You are writing another one. It is not the overridden one, it is a new one. Then it will be called method overloading. It will be overloaded again. Okay. It will go to previous rule. It will be overloaded. Overloading is what? Numbers of parameters should be different in terms of order, types, and numbers. The same thing happening here. So if you change the parameter, it will be overloaded, not overridden. Remember this, okay? So the second rule is, when you are overriding the method, parameter must be exactly same in terms of orders, numbers, and type. Implementation can be different because of why you are overriding. Next is method return type exactly same. So in show method we are not having anything, so it is void. When we are overriding, this is also void. In case of this one, return type is int, we are overriding, return type is int, no problem. Compile it. Compile. Extends. Here is the issue. Okay. Now compile. That is fine, right? Return type is add method overriding, return type is same, so no problem. If I change the return type, say return type I'm changing to string, and this is also changing to string. Now method is overriding, parameter is also same, method name is also same, only I have changed the return type. Okay, here return type is int, but in this return type is string. Now compile. Not okay. Add this in B cannot be overridden in this way. String is not compatible with int. Okay, method return type cannot be changed, it must be exactly same, int. But what we have seen in the previous method overloading, return type will not be considered. Okay, in case of method overloading, return type will not be considered. In case of method overriding, return type must be exactly same. But it has a condition. Okay, what is the condition? Let us take an example, another example. Okay, you already know what is primitive type and what is reference type, right? Primitive type is 8 primitive data type, byte, short, int, long, boolean, like this. Reference type is apart from this 8 primitive type, any other type is reference type. B, A, these are reference type or user defined type. So now add method is having a return type int, which is primitive. Add method is having return type int, again primitive. So if the return type is primitive, then it must be exactly same. If it is not primitive, if it is reference type, it has some condition. For example, 146 dot. So this is 146. Class A, currently nothing, empty. And class B extends A, right? Empty, nothing is there. This is also not having anything, empty classes. Okay, now I have class hello and class hi. Hi extends hello, right? Hi is the subtype of hello supertype. Now all these A, B, hello, and hi are user defined data type, means reference type. Now consider in class A, we have a method get instance is the method name, which is returning an object of type hello. Okay, this is a method return type is hello type. It should return an object of type hello. So what we will do, return new hello. One hello object is creating and returning that address. Now in B class, we are inheriting that get instance method. Okay, get instance overriding, which is already inherited, but we are overriding. So now return type should be exactly same. Okay, hello, and returning an object, say return new hello. Okay, compiling 146 if till this works fine or not. Test 146.java. Compiled okay, means no issue. Super class is having a method get instance, subtype is overriding it and keeping the return type same. Okay, if I change the return type to hi type, which is subtype, okay, and returning an object of hi, it is not exactly same type now, it is subtype. Now you compile. Okay, no problem, right? If so, it means in super type, if it is in super type, if it is in super type, if it is super type, super return type, in super class, existing methods return type is hello, which is super type. When you are overriding, it can be subtype. Okay, it can be subtype. So this is in case of when you are overriding and the return type is having some inheritance relationship and it is reference type. Then in super type, if return type is in super method, if return type is super type, in subtype, when you are overriding, you can change it to subtype of that super return type. Important point, remember, reverse is not okay. For example, if this is high, if this is high and returning high, now changing to hello, hello, and this is okay. When you are overriding, reverse. Previously it was subtype return type. Now return type is super type. We're changing. Compile this test 46. Not okay. You cannot do it. Okay. Remember this. So in case of method overriding, if return type is primitive type, it must be exactly same. If return type is reference type and return type is super type, then subtype can be, when you are overriding, return type can be subtype. That is okay. But reverse is not okay. Remember this, okay? Now, this is not this one, previous one. This is hello, and this is hi, and this is hi, which is okay. This is fine, right? This is fine. Compile it and execute. Execution, nothing is there, but compilation success means it is okay. This is a new features came from Java 5. Okay, from Java 5, this is the newly features implemented. Before to Java 5, even if the return type is reference type, it must be exactly same type when you are overriding. Okay, this is the next rule, third rule. Next, when you are overriding, related to access modifier. Take another example, 47.java. Test 47. Clean. And this is also not required. Class B. Extends A. Now, in these we have void show method. Overriding void show. Implementation currently I'm not giving. Whatever implementation you want, you can give. So this is overriding, right? Show method inherited, rewriting. So this is overriding. What is the access modifier for this one? You have not given any access modifier. When you are not giving any access modifier, what is the default access modifier? Default. When you are not giving anything, default. Default is you are not giving anything. And what is the accessibility? Default accessibility is a little more restricted than protected, but little less restricted than protected, but little more restricted than private. In package level, no restriction. Outside the package, you have some restriction. Okay, I'm not going into that part now. And you need to remember these orders. Okay, accessibility, public, no restriction, protected, little more restriction, default, little more, and private, completely restrictive. Okay, so these orders you need to remember: public, protected, default, and private. Now, when you are overriding, in case of overriding, method accessibility can be same. Okay, if you are not changing, that is okay. This is fine. We have seen so far whatever you have seen. Compile again. Java C test 147.java. This is okay, right? Now it is default scope. Nothing is there in it. But what I'll do, I'll make it protected. Protected. What is the difference? Which is more default or protected? Which one is more restrictive? Protected, right? Means you are reducing the accessibility. It was default. Now, okay, it was default. Now you are changing to protected, not increasing the accessibility, right? You are increasing the accessibility. If you are increasing the accessibility or you are keeping same, okay, means this should be okay now. Compile it. No problem. But if we reduce the accessibility, if we are not using protected, instead we are using private. Now reducing the accessibility. Compile. Not okay. You cannot attempting to assign a weaker access privilege. It was package level. Default means package level, right? So when you are overriding, you can use the same accessibility, same scope you can keep, or you can increase. You cannot reduce the accessibility, okay? In case of method overriding, accessibility cannot be reduced. It can be same or it can be increased. Same in the sense, if I keep public, you are increasing, right? Now it is okay. Fine, no issue, okay? Remember this point. Okay, so you can increase the accessibility or you can keep the same in accessibility, but you cannot reduce. Now, for example, if this is public, in superclass is public, in subclass, what we can keep? Can I keep default? From public, default is less accessible. You cannot access, right? Public is the highest accessibility. So compile, this is not okay. Not okay. It was public and you are changing. So you are assigning we cannot okay. If we give protected, that is also not okay, right? You are reducing. Protected is how? Public and protected. Protected is less restrictive. Protected is less restrictive. Save it and compile. Not okay, you're reducing. Okay, this is also reducing. So when the superclass method is public, when you are overriding, you must use public. Otherwise, it will reduce. You don't have any other option. Okay, compile now. Okay, remember this. When superclass method is declared as public, when you are overriding, you must declare it as public. If you don't use anything also, it becomes default, and default is more restrictive than public, means it will reduce the accessibility. So that is also not okay. This is the fourth rule. What are the rules we have seen? First one, method name must be same. Second one, parameter must be same in terms of orders, types, and numbers. Third one, method return type. Return type must be exactly same in case of primitive. In case of reference, it can be same or it can be subtype of the supertype. In case of accessibility, you can increase the accessibility or you can keep the same accessibility. You cannot reduce. Okay. Next is, assume I am not using any modifier. Okay. This should be fine. No issue, right? That is okay. Now this is an instance method, and when I am overriding, making it static. You know the difference between instance and static, right? Instance method is related to the object or the class. Each object separate copy of that method will be used. But static is a common for all objects. It is class level. So that is not okay. Compile. It was static, and you are overriding. You are overriding as static. It was instance, not okay. Okay, make this as static. Now overriding, that should be fine. Okay. Now this is making instance. Compile. Not okay. This method is static. So the rule is static method should be overridden as static, and instance method should be overridden as instance only. Right. So these are the rules you have to follow. We have some more rules in case of overriding related to exception handling. When we will see the topic exception handling, there again we will discuss this one. Right. So this is method overriding. Any question? What are the key points you need to remember? Method overriding is classes are not supposed to be modified because it may impact in other places. If you need to do any changes of the functionalities or implementation, you need to subclass and you need to rewrite the implementation. That is called method overriding. In case of method overriding, method rule name must be same. Parameter must be same in terms of orders, types, and numbers. Static method should be overridden as static. Instance should be overridden as instance. If the method return type is primitive, then overriding method return type also must be exactly same. In case of reference type, it can be same or it can be subtype of the super type. In case of accessibility, you can increase or you can keep the same accessibility. You cannot reduce, right? So this is method overriding. Remember another point. When you are overriding, if you change the method name, it will become overloading. Okay, it will become overloading. It will not be overridden. Next, any questions so far? No question, right? If no question, then next is very important concept. I'll take another example. Test 148. Class A and class B. I'm overriding a method. So, and the output is show method in A class. Similarly, show method in B. Okay. Now, if I create an object of A1 is new A and B1 new B. Right. Now with A1 I am calling show. With B1 I am calling show. This is overridden method. Okay, remember. So the output here should be show method from A, and here should be show method from B. This should be the output. It is nothing surprising this, right? A object you are creating, A is having show method, so coming from A. Show object you are creating, show is having show method, which is overridden, and it will come from show only. That's it. Simple. Compile. Test 148 and execute. Test 148. This is the output. It is a very simple one. But the concept here is like how we have seen in case of primitive type. Okay, what we have seen is, suppose I have a variable int A and okay, it has a value 10, right? Then I have a byte B. Can I keep A here? We cannot, because it is not constant. If it is constant and within the range, then you can directly keep. If it is not constant, then we need to typecast it to byte like this, and then we can store. But if it is constant, like final int x is 10, and now byte y is equal to x, it is okay, right? X is going to store into this because it is within the range, and you can store. Means int is of 4 byte, byte is of 2 byte, right? Or 1 byte. 1 byte, right? Higher to lower, higher to lower. A bigger size data you are storing into lower size. You can do it because it is within that lower size. 10 you can store easily into byte because it is within the range of byte. Similarly, if you have class A, and it has a subtype class B, now B is the lower type than A. So what you can do, you can create a reference variable of A1, and you can store new B. This is okay. The concept is similar like this. A lower data can be stored into higher type, upper type. Okay. Reverse is not okay. You cannot do like this. B1 is equal to new A. Not okay. This is not possible. This is okay. Right? Take an example for this. Similarly, here only we'll do. If we say A2 is new B, compile. Test 148. This is okay. Execute. Fine. We are not doing anything, so this is okay. Okay. Super type reference variable subtype object is okay. If we do reverse, B2 new B, sorry, new A, not okay. Compile it. This is not okay, right? So this is not possible. No chance. But reverse is okay. You can super type reference variable subtype object. You can store. This concept is called dynamic dispatch. Okay. Super type reference variable subtype object. This is called dynamic dispatch. Very, very important. Okay. So following this concept, suppose you have classes something like this. A, B, C, D, E, F. This is an inheritance, okay? A is having two subclass, B and C. B is having one subclass D, D is having one subclass E, C is having one subclass F. Now, if you follow the dynamic dispatch, I'm creating A1 reference variable. Now, what we can do, A1 is equal to new A. Okay, this is not dynamic dispatch. A1 is equal to new B. Okay, dynamic dispatch. A1 is equal to new C. Okay, dynamic dispatch. A1 is equal to new D. Okay, A1 is equal to new E. Fine. A1 is equal to new F is also fine. Okay. For A, D, and F and E is not direct subclass, but these are subclass. Okay, indirect subclass, but these are subclass. If we create B, B1, now what we can do? B1 is equal to new B. Okay. B1 is equal to new A. Not okay. B1 is equal to new C. Not okay. B1 is equal to new D. Okay. B1 is equal to new E. That is also fine. So these are dynamic dispatch. Okay. If we take a C reference variable, it can have only C and F object. If we have D reference variable, it can have only D and E object. If the reference variable is of type E, then object can be only of type E. If the reference variable is of type F, object can be only of type F. This is dynamic dispatch. Remember this. Very, very important. So now, in case of dynamic dispatch, another important concept. Take another test. In case of dynamic dispatch, 149.job. A show in A and this. Sorry. Another take here. Void M1. And in these M1 method in A, and in this M2 in B. Okay, M2 in B. Now I'm using dynamic dispatch. A1 new B. Okay. Now in case of dynamic dispatch, how function works? Very importantly, remember, in case of dynamic dispatch, how we have created now, A1 is new B. And this is A1 of size 8, which is of type A, pointing to an object, this, which is of type B, 1040, assume this is 1040. Now, when we call any method in this scenario, if it is in dynamic dispatch, first you understood what is dynamic dispatch, right? Dynamic dispatch is super type reference variable subtype object. This is called dynamic dispatch. Now, in case of dynamic dispatch, when you call any method, suppose I am calling A1 dot some X method. Okay, what it will do is, first it will check this X method is available in reference type or not. What is the reference type? Which one is the reference variable? Reference variable is A1. A1 is of which type? A type. So X is available in A or not. It will check. Okay, it will just check. If it is available, it will call the function from the object type. Which is object? This is object. Object is of which type? B type. Then this function has to call from B. Clear, right? Remember, listen one again. When you are using dynamic dispatch and you are calling a method, in that scenario, the method signature will be verified in reference type. Here reference is A1, which is of type A. So X function will be verified in A type first. If available, it calls that from the object type. Object is this one, which is of type B. So this X function will be called from B. Okay, this condition has to satisfy, then only function will be called. If X signature, if X when it is verifying into reference type, if not available, it is a compilation failed. It will not work. This condition has to satisfy. Now come back to our example. This is dynamic dispatch and I am calling A1.show. It will verify show in reference type A of A type. In verify show is there or not, it is there. If it is there, it will call from object type, means the output should be this one, show in B. Here the output should be show function in B. Compile and see this. Test 148. Okay, execute. 148. 149. Sorry, 149. Java. What happened? Java C. Test 149.java and execute. Test 149. Okay, show in B. So it is verifying in the reference type. If it is okay, it will call from the object type. Come into this one, M1. A1.M1. Now what will happen? Same, okay. M1 will be verified into reference type. M1 is available or not available. It will just verify it is there or not. If it is there, it has to call from the object type. Means M1 has to call from B. But B M1 is not there. What will happen? Inherited one will be called. What is inherited one? The same only, right? This one. So the output should be M1 in A. This should be the output. Remember the logic. The logic remains same. Okay. M1 has to verify in the reference type, should call from the object type. But currently in object type it is not implemented. So it will call from the inherited one will be called. Compile again. Test 149 and execute. Is this fine? Come to the next one. A1.M2. Now where is M2? M2 here. It will verify M2 into A. M2 is there or not? Not there. Compilation failed. Compile it. Not okay. Not saved. Save it and compile. M2 cannot find symbol. Where? In A type. In A type, M2 cannot find symbol. Okay. So newly implemented method in subtype will not be accessed through dynamic dispatch. Through dynamic dispatch, newly implemented method will not be inherit. You cannot call with the dynamic dispatch. Very, very important topic. Okay, please do not miss the classes these days. These are very, very important topic we'll cover. Fine. Any question till this? No question, right? So next we'll continue tomorrow. Thanks everyone. Bye-bye.